welcome back to Let's Get Ready. So right now you should be doing the Algebra 1 unit, and this little video right here is going to be focused on Joe Bloggs 2.0. So, just something to remember, you already talked about Joe Bloggs in the test taking strategies part 1, but the important thing to remember is that the SAT loves to trick people. So when you get a question, it'll have an obvious answer there that it wants you to choose, but the point of the SAT is to test your skills and knowledge, so you're going to want to do out all your work before you answer the question too easily and too quickly. So just 3 important things to remember. Always try to show your work just for yourself so that you can see better what the question is asking for, which may lead you to the answer that's not so obvious. Don't rely on your calculator. I know if you have it there, you want to use it to just check and to confirm with yourself, but sometimes that can mess you up. Trust yourself to know what the right answer is, but also make sure that you're putting in the work, and just remember your basic arithmetic rules. So with that, let's just move into a couple of problems. So the first one we have here is this problem right here on the top, which is just asking for what the answer is. So on the top, you have x to the 6th plus x to the 5th plus x to the 4th plus x to the 3rd over x to the 5th plus x to the 4th plus x to the 3rd plus x to the x squared. And it's asking, it's a multiple choice question, so here are our answers right here. What would be a typical, if you were Joe Bloggs and you were just trying to do this really quickly, what you might think to do is to cross off these terms and say, okay, well, there's an x-fifth on the top and on the bottom, and here's a 4 and a 4 and a 3 and a 3. But one of the things that I said in the first slide was, remember your basic arithmetic rules, and for this one, the problem here is what we have is we're not multiplying or dividing all of these terms, we're adding them together. So you can't separate them and cross off one on the top and one on the bottom, because technically this whole top is one term and the whole bottom is one term. So have it right here again. What you're going to want to do is to take out an x from the top. And when we do that, when we take out an x, we're getting rid of an x for each of these terms. So x to the 6th becomes x to the 5th, x to the 5th becomes x to the 4th, x to the 4th becomes x to the 3rd, and x to the 3rd becomes x to the 2nd. And if you were to multiply this x to each of these terms, then you would end up like this. So this right here at the top is the same thing as this thing, we just took out an x. And when we did that, now technically we can cancel out what we wanted to do when we first saw the problem, because now we have 2 terms. This is our first term and this is our second term, and on the bottom we have a term here too. So we can cross off this whole entire term because all of this matches all of this. And that just leads us to x. So again, Joe Bloggs, really quickly, you would want to be crossing off all these things, but we can't do that because they are combined together with addition. Similarly, if these were subtraction, you couldn't cross off the top and the bottom ones. They're all together. But as soon as we took out that x, now our terms match up, so we can cross off the top and the bottom to leave us with just x. So the answer here would be D. Okay, moving on to our second problem. We have, are the following equal or not equal? So looking at this problem really quickly, you could choose maybe an answer, but let's do it out. So I just, down here is the same exact problem, but just more space to work with. The first step I would say to do is to distribute this 3 into the parentheses. So we're going to multiply this 3 times 2x. Remember this negative sign right here. So that's going to be negative 3 times 2x, which is going to lead us to negative 6x. And then we're going to multiply that negative 3 times 4. But also remember this negative sign right here, or the subtraction sign. So we're going to think of this term as negative 4. So we're multiplying negative 3 times negative 4. 2 negatives equal to positive. So that's going to be plus 12. Now, quickly looking at this, they don't look exactly the same. This is a negative 6, and this starts with a 12, and then we're subtracting, and here we're adding. But taking a second to readjust, we can see that they are actually the same. Because if we were to rewrite this, it would be 12, because it's a positive 12. And so here because there's no negative sign in front of it, it's positive 12. And here we have negative 6, but when we put it in an expression here, it's 12 minus 6, which is the same thing that we have on the right side. So this would mean that this problem is equal. Okay, now we're gonna go into a couple more practice together problems to really just nail this home. So the first problem we have here is, and the question's asking, are these two expressions equal or not equal to each other? So this one is x times x plus 7 in parentheses plus x plus 7 in parentheses. And we're wondering if that's equal to x squared plus 8x plus 7. So again, this is the same thing. I just put it down here so I can have more room to work with. So what we're going to do is, like we did before, we're going to distribute. So we're going to multiply this x times this x. X times x is x squared. Then we're going to multiply this x times this 7 right here, and that's going to equal 7x. And then we're left with, because this is combined, we're not going to distribute that x over here. There's a addition symbol to separate that. We're going to do plus x plus 7. So we can just get rid of that parentheses sign because we're adding here in order of operations. It doesn't matter what you do here, you're just going to be adding. So looking at this problem really quick, we can think, oh, there's 4 terms here, there's only 3 terms on this side, must not be the same. However, take a pause and look at this equation again. And we can see that we have 2 like terms here because this is only x and this is only x. It's not x squared. So we can actually combine these 2 terms, and now our expression on this side looks like x squared plus 7x plus, technically 1x would be 8x plus 7. And here on the left we have x squared plus 8x plus 7, and that's the same thing as the right side, which is 8 squared plus 8x plus 7. So are the following equal or not equal? They are equal to each other. Okay, and now moving on to our second problem. We have, so this is the same question as before, I just screenshotted them, so it's asking whether this is equal to this. And so on the left we have negative 2 times x plus 1 in parentheses plus 5, and then 2x plus 6. Looking at this really quickly, we could think, oh yeah, well there's going to be a 2x, and 1 plus 5 is 6, so they're probably equal. But let's do out the work so that we don't get tricked by the SAT. Again, we're just going to distribute that negative 2 to this x. So now we have negative 2 times x, which is negative 2x. Then we're going to distribute that negative 2 to the 1. So negative 2 times 1 is going to equal negative 2. And then we have plus 5. So now we can combine these two like terms. There's no x's with them, so they can be combined. So now our equation looks like, or expression looks like negative 2x, so minus 2 plus 5, that's going to equal negative 3. So is negative 2x minus 3 the same thing as 2x plus 6? No, it is not, so these are not equal to each other. Okay, and finally, our last problem. The question again is whether these are equal to each other or not. So we have 3y plus 5 in parentheses minus 2y minus 4, and we're wondering if that's going to equal to y plus 1. Looking at it quickly, we can be, maybe they are, you have a 3 and a 2, so that's going to be a y, but and a 5 and a 4, so that could be a 1, but let's do it out. So again, here's the problem down here with just more space. The good thing here is that we don't have any numbers next to our parentheses. It's all addition and subtraction, so we can get rid of those parentheses so that it kind of looks like one expression. So this is going to look like 3y plus 5. Here's where it gets a little tricky. We're going to want to distribute this negative sign to our terms inside of this parentheses. So this is going to be minus 2y, and then we're going to distribute that parenthesis, so we distributed that there, we're going to distribute that negative sign to this. So instead, we can treat this as like a negative 1. So it's negative 1 times negative 4, which is going to equal plus 4. So when we combine our like terms, sorry, this is a y, we have a 3y minus a 2y, so that's going to equal just y. And then we have 5 plus 4. So that's actually going to equal 9 and not 1. If we had just done this really quickly, we could have just done 5 minus 4 and then that would equal 1, but that's not the correct arithmetic. We want to distribute that negative sign to both sides and we get y plus 9, and so y plus 9 does not equal y plus 1. Okay, so that's going to do it for Joe Blogs. Just remember, SAT loves to trick people. Do out your work, trust yourself over a calculator, and you guys will be fine. So I hope you enjoy the next lesson.